multiplicities of zeros of polynomial functions. So our objective for this video, identify zeros and their multiplicities, and identify how this affects the graph of the polynomial. Okay, so what do we know coming into this video that's going to be useful? Well, we know what a polynomial function is. A function of the form f of x equals coefficient times x to a degree plus coefficient times x to a degree, etc., plus a constant. And we want to note and remind ourselves that when our degrees are listed in numerical order from greatest to least, it is in standard form. Number two, we know what the zeros of a function are. They are the value or values of x for which f of x is equal to 0. They're also called roots or solutions, and each is an x-intercept of the graph of the polynomial function. And number three, we know what factoring is. Factoring is finding what to multiply to get a polynomial. Writing a polynomial as a product of factors. And we talked in a previous video about factoring and the various ways you can do it. Greatest common factor, grouping, how to factor a trinomial, a difference of squares, etc. And we use factoring along with the zero product property as a method for finding a function's zeros. Okay, let's take a look here and let's define multiplicity. Give me a second to move some things out of the way. Okay, so what is multiplicity? Get my paper straight. Multiplicity is simply how often a certain zero is part of the factoring. How often a certain factor occurs. Okay, so let's take an example here. We've taken a 6th degree polynomial and we factored it. And here's how it was factored. F of x is equal to x minus 5 cubed times x plus 7 times x minus 1 squared. We factored this 6th degree polynomial, and you can see the 6th degree here. We have 3x's here. If we were to multiply this out, we have 1x. I'll put a 1 right there for that factor. So there's 1x, and then this, if we multiply it out, becomes a quadratic. So 1, 2, 3, 4, 5, 6th degree polynomial. Now, we'll note here that our zeros are 5, -7, and +1. Okay, let's expand it. We got 3x minus 5, so there's 1, 2, 3. I just wrote this in expanded form. I have 1x plus 7 factor, and I have 2x minus 1 factors. So here it is expanded with the exponents all written out, the exponential terms written out, expanded. And we can see here that the 5 occurs 3 times. So 5 is a 0 with multiplicity 3. 1, 2, 3. Same as the exponent. I just wrote it out so we can see it. -7 is a 0 with multiplicity 1. -7 occurs as a 0 1 time. Here it is in the expanded form, and here it is in the factored non-expanded form. And finally, the 1 here is a 0 with multiplicity 2. 1 occurs as a 0 twice. Here are 2 factors, and here it is in exponential form. So what does this multiplicity tell us? Well, the multiplicity of a 0 tells us whether the graph of a polynomial function touches the x-axis at the 0 and turns around, or if the graph crosses the x-axis at the 0. Okay, so we're going to have 2 choices. And this is done through even versus odd. If the multiplicity is even, so for example, the 1 up here in this example, the 1 occurs 2 times as a 0. If it's even, then the graph will touch the x-axis at this 0, in this case at x equals 2, at the 0 at the x-intercept, and it'll turn around. It will not cross. It'll simply come up and touch it and turn around at x equals 2, or come down and touch it and turn around at x equals 2. Those are for zeros that have even multiplicity. If a 0 has odd multiplicity, so for example, our 0 of 5 occurred 3 times, our 0 of -7 occurred once, so these two have odd multiplicity, then the graph is going to cross the x-axis at this 0 or at this x-intercept. So at x equals 5, the graph is going to cross, either coming down from left to right or going up from left to right. It's going to cross the x-axis at x equals 5. Let's take a look at some examples to help us. Just a moment, let me get myself together here. And of course, we'll also take a look at the graphs as well. So, example number 1. Find the zeros of f of x is equal to -4 times x plus 1/2, the quantity squared, times x minus 5, the quantity cubed, and give the multiplicity of each 0. State whether the graph crosses the x-axis, or touches the x-axis at each 0 and turns around. Check your answer with your graphing device. Well, we're going to note here, this is already factored. Okay, we've already broken this into a multiplication of factors. Constant factor, a factor of x plus 1, which occurs twice, and a factor of x minus 5, which occurs 3 times. Okay, so we know how to find our zeros. We set it equal to 0, and as necessary we factored, but this is already factored, so we're done. Okay, so what are my zeros? Well, I have a 0 here when x equals -1/2. Okay, so I have zeros at x equals -1/2, because -1/2 plus 1/2 is 0, and by the zero product property, 0 times anything is 0. And x is equal to 5. When x is 5, 5 minus 5 is 0, 0 cubed is 0, and of course 0 times anything is 0. So those are my zeros. X equals -1/2 and x equals 5. Okay, well let's take a look. -1/2 has multiplicity what? I'm going to abbreviate, I'll write multiplicity out. P-L-I-C has multiplicity, well, 2. The factor x plus 1/2 occurs 2 times, so this has multiplicity 2. Okay, well that is even, right? 2 is an even number, so the graph touches the x-axis. Okay, where does it touch? What happens at 1/2? The graph touches the x-axis at x equals -1/2, okay? The graph touches at x equals -1/2 and turns around. Okay, so because it has an even multiplicity, the graph comes down from above and touches at x equals -1/2 and goes back up, or the graph comes up from below and touches it and goes back down. We're not sure which it is. Okay, let's take a look at our other 0 at x equals 5. Well, the 0 at 5 has multiplicity of 3. The 5 occurs 3 times, has multiplicity 3. Well, that's an odd multiplicity, which means the graph crosses the x-axis at x equals 5. Again, we don't know if it crosses by going up from left to right or if it crosses by going down from left to right. We just know that it crosses. Okay, let's take a look and see what we get here. I think I've got the I think I got my light in the way here. Let's try to find a way to get that. I think I got it over here. The light probably should be out of the way. Okay, let's go into my y equals and clear it. And I'm going to put this in here. So -4 parenthesis x plus 1/2 close squared times parenthesis x minus 5 raised to the 3rd power or cubed. Let's graph that. And looks like I've got, maybe I'll just put this back into standard form here. Yep, I've got things going on here. Let's put this into, let's go to my window and go to, go from -10 to 10. So I can get in, because I had it at 5 there. So there we go. A little bit better. That's kind of coming in quickly, isn't it? And there's the cross. All right, well, let's shrink it. Let's zoom in on the y-axis a little bit. And let's have the y go from -2 to 2. And see what's going on here. Oh, we're not even getting it. It's coming in, but it's having a hard time showing it. Okay, so let's go back into my window and have it go from -1 to 6, and we're going to scale by 0.5. Maybe that'll help us. Well, we're not quite getting this one for whatever reason. There's okay, we know that one's okay. So we know that this is our -1/2. So let's go to our calc. We want to calc a 0. And we want to be between, let's see here, left bound. Where's my left bound? I want to be my left bound. I want to be in the negative. So I want my left bound, there we go. I want my left bound to be over here around -1. And you can see now I've got a left bound here. And let's set my right bound to the other side. Okay, press enter. So I want to be between these two. And what is that 0 right there? And let's press enter. Take a guess. Whoops, something happened to your graph. Let's go back. My 0 and my left bound, I want to be here. And my right bound, I want to be over here. And then I want to guess. Oh, it's something, there's no sign change. So this calculator is telling me there has not been a change in the sign, so it can't give it to me. So the calculator has an issue with this one. But we can see, if I go back into the graph, let me go back and quit here. If I go back into the graph, that is at 1/2, because I counted by 1/2. And the graph is coming down and then going back up and touching it. So there is the multiplicity of 2, where it is touching, in this case, coming down from the left, touching the x-intercept going back to the right. Okay, I'm curious if I press trace and I put in -0.5. Okay, I do get a 0, so there you can see it. I press my trace key. There's my x is -0.5 and the y value is 0. So I just don't have enough pixels apparently to appropriately draw that. And then over here is 5, x equals 5, and you can see it's crossing right at 5. Again, I'll go back to my trace. I'm in trace, I'll put in x equals 5, and you can see I have a 0 there where I'm crossing. So an even multiplicity, come down and go back up. In this case, sometimes it goes up and it comes back down. It touches and doesn't cross. Odd multiplicity, it crosses. Oh, a little bit of work with our calculator there, with our graphing calculator. Let's take a look at a second example. Okay, find the zeros of x cubed minus 2x squared plus x and give the multiplicity of each 0. State where the graph crosses the x-axis or touches the x-axis at each 0 and turns around. Check your answer with your graphing device. So this is not factored. It's a 3rd degree polynomial. And I do notice that I have a greatest common factor of x. I'm going to pull that out. x squared minus 2x plus 1. Okay, well this, I know, I mean, we can factor this. So let's see, this is a trinomial, and this is x minus 1 times x minus 1. Okay, and we can see that factor 1 occurs twice. If you want, I'll just go ahead and rewrite it as x minus 1 squared, so we can have the multiplicity of the 0 x equals 1 written down here as the exponents. So the zeros are 0, 0 times anything is 0, and positive 1. Okay, those are my zeros. Let's see here, 0, the x equals 0 has multiplicity. There's a 1 here. So this has multiplicity 1. Has multiplicity, P-L-I-C, of 1, which of course is odd. So we know graph crosses the x-axis at x equals 0, and the other 0 is 1, and the 0 at 1 has a multiplicity of 2. Whoops, I've already spelled the word has. I need to write multiplicity, which of course is even. So the graph touches the x-axis at x is equal to 1, and it turns around. Again, we don't yet know how that works, but we know that this is what happens at x equals 1. Let's take a look at this one, and hopefully we'll have a little better luck with the graphing calculator. Okay, x cubed minus 2x squared plus x. I'm going to go into zoom and do a standard here, get back to the negative 10 to 10. Okay, there we go. So we've got something going on here. The zeros are, all right, did I put my incorrectly? X cubed minus, oh, I forgot the 2. I know I forgot something because it didn't look right. Insert a 2, there we go. Let's try again. I knew my graph didn't look right. Okay, now let's graph it. We should come out a little more correctly here. There we go. Now let's zoom in on this one. So let's go to my window. We want to really focus between negative 2 and 2 here. So let's go from negative 2 to 2, and we can even do the same thing with that y-man from negative 2 to 2. And now let's look at it. Here it comes. Okay, so now you can see at x equals 0, the graph is crossing. There's the multiplicity that's odd. In this case, it's 1. And here at x equals 1, it's coming in from above, it's touching it, and then it's going back out. So it is touching the graph and then turning back around there at the 0, x equals 1. So there you have it. Odd multiplicity crosses, even multiplicity touches and turns around.